The first part of this question is fairly straightforward. We're writing the function c of t using the compound interest formula that you should be familiar with. Just a quick refresher, I did a little image here of how that works. So P, representing the principal amount, would be $63,000. That's the amount she's initially putting in there. That's going to be multiplied 1 plus R. Now R represents the interest rate as a decimal. So 2.55% as a decimal would be 0.0255. And that's going to be over n, which is the number of times the interest is compounded per year. Since we're told it's compounded monthly, that means n has a value of 12. And then that's going to be to the power of nt, n again being 12, and t representing the number of years. So that's it. That's the first part of the question complete. Now for the second part of the question, we're asked to calculate the number of years it would take for the account to reach $100,000 to the nearest hundredth of a year. So in other words, we're trying to calculate the value of t given that c of t is equal to 100,000. So let's go ahead and write that out. So 100,000 equals 63,000. Inside the brackets here, if you calculate 1 plus 0.0255 over 12, we get 1.002125, and that's the power of 12t. Now, one quick way we can simplify this equation is to divide both sides by 1,000. And essentially, by doing that, we'll be eliminating 3 of these zeros. And the other thing I can do is divide both sides of the equation by 63. So then we'll be moving that 63 over like this. So now we have 100 over 63 is equal to 1.002125 to the power of 12t. So now, because we have an equation with the variable we're trying to solve in the exponent, we're going to take the log of both sides. Now, since we're doing that, if you remember, one of the logarithm rules we can do is we can take this exponent and move it to the front here. So now we'll have a log of 100 over 63 is going to equal 12t multiplied by log of 1.002125. Now, to actually solve for t, what I'm going to do is I'm going to divide both sides of the equation by everything else. I'm going to divide by 12 log of 1.002125. So that means t we can find by taking log of 100 over 63 and dividing it by 12 times log of 1.002125. And when you calculate that out, you should get a rounded answer to the nearest hundredth of 18.14 years. All right, that would be it for this video, and thanks for visiting JD's Preparation.